Video 6, what's up, playa haters? Now, this video is entitled, at the top of your notes, One-Sided. And what does it mean that we're really talking about a one-sided test? Well, when our alternate hypothesis uses a greater than or a less than sign, we're only considering one side of our z-score, our test statistic that we will be calculating. Now, we will discuss specifically two-sided tests more in the next video. So in this one, we're really only going to be talking about to the left side of the z-statistic or the right side of the z-statistic to calculate our p-value. Now, conditions. We've already talked about these in a previous video. They are all the same as they were in the previous video. The main thing, again, to note that was different in our conditions between this chapter and the last chapter was in the normal condition, that you're not going to be checking n times p hat and n times 1 minus p hat. The p hat is really the p sub naught, which is the value that we're going to get from our null hypothesis. That p is really equal to whatever that number is, that is our p sub naught. And that's the number you're going to plug in to your formula to determine whether the sampling distribution can be assumed to be approximately normal. Now, last video we talked about this general formula here, okay, that our test statistic z is really our statistic minus our parameter divided by the standard deviation of the statistic. Now we're going to turn this more mathematical instead of words. So all of this will turn into this. So again, our z is our test statistic in proportion problems. The statistic we are referring to is the p hat that we will derive from a sample. The parameter we're going to use is that p sub naught that we're going to get from our null hypothesis. And then the standard deviation of the statistic, this is really our sigma sub p hat, which we have used in the past 2 chapters, and it's kind of morphed into various forms. But instead of using p hats underneath here, we're going to continue to use our hypothesized value for our population proportion. So we're going to use p sub naught down here instead of p hat. So this, again, is going to be a little bit different than the last chapter. Last chapter we used p hats, but in this chapter we are not. Now the p-value is the area under the curve that is as extreme or more extreme than the z-score that we are going to calculate. And just like we mentioned last video, we are going to be using normal CDF to find the area for our p-value. Okay, and we talked about that we would usually need to know 4 numbers to use normal CDF, our lower bound, upper bound, mean, and standard deviation. But since we're always going to be dealing with a standard normal curve, all we really have to use is the lower and upper bound. The mean and standard deviation will be the defaulted 0 and 1. Now, if our p-value is less than our predetermined alpha value, then that's when we got to say the hoe got to go. Okay, we're going to reject the null in favor of the alternate. Now, here's what's going to be important. Here is our stereotypical statement that you are going to have to write for the conclusion. That you're going to say, we do or do not have enough evidence, and we'll talk about which one you circle here when I get done finishing here. So either you do or do not have enough evidence at the, and then fill in the blank, what is your alpha level? You know, typically it's going to be the 0.05, or you could say 5%, to conclude that the, whatever your population parameter and context is, whether it's, you know, the mean length of battery life for all, and who's your population, we'd say for all batteries, is the very end of this is always going to refer to the alternate hypothesis. Okay? So whatever the alternate hypothesis is, you state that always at the very end of this concluding statement. And now to go back to the beginning of this statement, you either do have enough evidence to conclude that the alternate hypothesis is what you want to go with. So if you say we do have enough evidence, that means that you rejected the null hypothesis. Alternatively, if you fail to reject the null hypothesis, then you would say we do not have enough evidence to conclude the alternate hypothesis. So again, the very ending of this statement here is always in reference to the alternate hypothesis. And either you do have enough evidence to go with the alternate hypothesis, or you do not have enough evidence to go with the alternate hypothesis. Now a question, do you have to write down the test statistic, the z-score, to receive full credit on problems when all we really need and use is the p-value to determine if we reject the null hypothesis? So some of you might say, well, we're going to get a z-score, and then we're going to use the z-score with normal CDF, and from normal CDF, we're going to get the p-value. And that's the main thing we really need to make our decision of rejecting the null hypothesis or not. Do you still have to show all the work for the z-score, and what is the z-score? Yes. Okay, I've checked on the AP exam grading rubrics, and they require you to write down the test statistic that you calculate, that z-score. So you must write it down. If the AP exam requires it, I require it as well. So two numbers you're always going to have to report will be your test statistic, your z-score, and the p-value. And then you will decide from the p-value whether to reject or fail to reject the null hypothesis. So the example we're going to look at, and this is, believe it or not, an actual case that is pretty local for our area. I just happened to find this in a book. It says, in the case of Hazelwood School District versus the United States in 1977, the U.S. government sued the city of Hazelwood, a suburb in St. Louis, on the grounds that it discriminated against blacks in its hiring of school teachers. The statistical evidence introduced notes that of the 405 teachers hired in 1972 and 1973, the years following the passage of the Civil Rights Act, only 15 had been black. The proportion of black teachers living in the county of St. Louis at the time was 5.7% if one does not include the city of St. Louis. So we're going to state our hypotheses, calculate the test statistic and the p-value, and then what conclusion would we make? Now, just for this example, we're going to kind of bypass the conditions. Because really, did we have a random sample of teachers here? Probably not. We had just the available data given to us. So just, again, for this example, we're going to skip over the conditions. We're going to assume that they have been met. So we're going to do all the statistical work that was really presented to the courts in showing whether Hazelwood was guilty of discriminating against blacks or they weren't discriminating against blacks. Okay, so I'm going to scroll this up a little bit so I can get some extra room here and leave all the important information up here. About right there is what we need. So the null hypothesis is that the proportion is 5.7%. Okay, so we'll write it as a decimal here. We think the proportion of black teachers hired should be the same as those living in the county. Versus alternatively, we're trying to show that they discriminated, that they really hired less than the percent that live in the county of St. Louis. Okay, where P is our proportion of black teachers, or black teachers hired, we'll say. All right, so again, this would be step number one, stating our hypotheses and defining our parameter. Step two would be our conditions, which I said for now, you know what, we'll skip over that. We'll assume that's true. So then we'd move on to step three, our calculations. And we need to calculate a test statistic, a z-score. So our formula was p hat minus p sub naught over the square root of p sub naught times 1 minus p sub naught all over n. So let's talk about what these values really are. So p hat, this is from our sample. Well, our sample said that 15 out of 405 teachers had been black. Well, there's our p hat value. So p hat is 15 out of 405. And let's just talk about what that number is as a decimal here. So that's really 0.03704 if I want to do 4 sig figs. So this number is less than the 5.7%, but is it far enough less than 5.7% that we could claim discrimination? That's what we're going to figure out. So our p hat is our 0.03704 minus, now remember this value, our parameter, comes from our null hypothesis, our 0.057, divided by the square root of our still 0.057 times 1 minus 0.057, all of that over our sample size, which is our 405. So now, if I want to get a z-score out of this, let me see here. I get a z-score that is approximately negative 1.733. Again, if I do 4 sig figs there, which is 3 decimal places. Okay, so there's my test statistic. And with my test statistic, I want to calculate a p-value. Okay, so really our sample of 15 out of 405 is 1.733 standard deviations below the mean, which is assumed to be this 5.7%. All right, so now let's take all this and let's move it up. So now we want to find the probability of obtaining a z-score that is, now which way do I want to go? Oh yeah, I want to go less than my z-score, negative 1.733. And I will be using normal CDF. And if we're using normal CDF, we're going to want to have a picture here. So let's draw a quick little picture of a normal curve. Negative 1.733, we're close to 2 standard deviations. We'll estimate that it's maybe right here. So here's negative 1.733, and we want to shade to the left, because that's less than. And so whatever the area of this shaded part is, that is our p-value. Okay, so our lower bound, which should be over here, would be negative infinity, negative 99999 in your calculator, up to the upper bound, which is our negative 1.733. And that's it. Don't worry about the mean and standard deviation. It's still 0 and 1. So we should get a p-value that is, for my calculator, I get 0.04156. So there's our p-value. Now, we stated our hypotheses, we calculated the test statistic, we've got a p-value. Now, what conclusion would we make at the 5% significance level? So here's number 4. Here's our conclusion. And this is where I want you to start writing that statement that I commented on back here. This is what we're going to write. Oh, too far. We're going to say, now do we or do we not have enough evidence to reject the null hypothesis? Well, our p-value is less than the 5% significance level. So we will say we do have enough evidence at the 0.05, or we'll say alpha, well, back it up a little bit here. At the alpha equals 0.05 level to conclude that the proportion of black teachers hired in the whole district, that's kind of referring to our population here, is, now this is where we refer to the alternate hypothesis. We always refer to the alternate hypothesis, whether we do or do not have enough evidence to conclude it. So our alternate hypothesis was that it was less than the 5.7%. So we concluded, just like in the court case, the actual court case, that the city of Hazelwood their school district was in fact discriminating against hiring of black teachers. So there is an actual case of where statistics came in handy to further promote the Civil Rights Act so that, you know, job equality was further promoted in the city of Hazelwood. So here's the example in the book. And again, you can pause the video at this point, kind of read over what's going on here. I've already got part of the answers going on here. Here's where we're stating the hypotheses, and then here we're checking the conditions down here. So pause the video so you can read over this. And here's the rest of the problem. Here's the calculations. Just keep in mind for the calculations, they may refer to in the book of using table A, but I will never personally use table A. I'll always use the calculator. So I will do what they did here using normal CDF. And if we use normal CDF, we need this nice picture over here. And here's our conclusion down here. And then here's the problem I want you to try and work on and bring to class, and we will go over it the next day. So I bid you adieu and goodbye.